Hey guys, so today I'm going to be doing my first episode on my tutorial series on how to make a game in Android Studio. So in this episode we're going to be learning how to create the game loop, which is going to be the meat of our game. And I'm going to assume you already have Android Studio installed, but just in case I'll show you guys where you can get it. Just open up your browser and search Android Studio. Click the first link right here, or actually just click the ad. Here's the link if you need it. You just go to developer.android.com. And you should see a screen right here that prompts you to download the software. Just click download for Windows, or install your corresponding software for if you have a different operating system. But once you have that downloaded, go ahead and open it up and create a new Android Studio project. I'm going to name it Tutorial, and as you can see, there will be a slot for company domain. By default, it'll just have whatever your name you signed up for Android Studio with, but of course, if you have a company, you can go ahead and change that. I'll do Retro Chicken. And then here's just where it's going to save the project. I've created a folder for tutorials, so that's where I'll be saving it. Click Next. Here's where you want to select your minimum SDK. And what that is, it's just going to specify what level of software API your devices that it can run on have to have, the minimum. And it'll tell you how many devices will be able to play it based on which one you select. You want to keep it relatively new, but you want to have a lot of the people being able to play it. So obviously this is 1.3, it's not good. So I'll go with 18 because it's relatively high and has 75% of the people can use it. Click Next and then select empty activity. And just keep that as is. Click Finish. And we're going to let this load up. All those other activities you saw are good for if you're making an app, but for a game we're going to be deleting that all anyways, so we don't need it or want that there. Okay, so here we start out with our main activity. Our main activity is where our app will start out when we load it, and essentially activities are just a combination of Java code, which we have right here, as well as a corresponding XML file, which I'll open up right now, which basically just stores our layout, which we won't be using once again because we're making a game, not an app. But if you're making an app, it has a lot of useful tools right around here that you can design using its rendered version. But we're not going to be bothering with that. So first thing you want to do is change this from app compact activity to activity. Secondly, what we're going to want to do is we are going to want to get rid of the toolbar at the top and make it full screen. So we'll make it full screen first. So get window dot set flags, window manager dot layout params dot flag full screen, comma, and we need a second argument. So just go ahead and copy and paste this as the second argument. And then now to get rid of the toolbar, we'll do this dot request feature, or request window feature, window dot feature no title. For some reason that didn't autofill, so that's good. And then lastly, on this set content view, we're going to set this to a new game panel, passing in this for the constructor. Which is going to be a class which we haven't quite made yet. We'll do that right now. So right click your folder, your package, and we're going to make a game panel class. And what we want to do for the game panel here is first have it extend surface view. Oh boy, I can't type today. Okay, and it implements surface holder dot callback. And of course we have errors because we have to implement a few methods, but first we'll make a private main thread, which is also a class we'll be making later, right after this one. And we want to make our constructor, which is going to take in a context On Android Studio, the hotkey for imports is Alt-Enter, so just press Alt-Enter, import class. Okay, we're good there. And then we want to call super, and we also want to do getHolder.add callback this. We're going to set our thread to a new main thread. I'll do ... for now because we haven't made that, but I don't want it to call default constructor, so we'll save that and then come back. And then we're going to set focusable equal to true. And actually, for those of you that just want to fill this in, I'll actually give it to you guys. We're just going to pass getHolder, comma this. That covers that constructor. And now we're going to override a few methods. So we want to do surface change, which takes in a surface holder, an int, another int for width, and an int for height. And we are not going to do anything with that, but we're just going to override it. And the next one is very similar. It's on surface created. Here we go, surface created. That once again also takes in a surface holder. And in the surface created, it makes sense that we're going to want to basically restart our main thread, or rerun it. So we're going to have our thread equals a new main thread. And it's going to be getHolder. Always autofills that, but getHolder, comma this, just like we did up there. And then we're going to do thread.setRunning, which later will make our game loop start running. And we're going to call thread.start, which is just a method inside the thread class, which our main class will extend. And that's just a class in the Java packages. Finally, or well, not finally, but out of all these surface created, destroyed, and changed, this is our last one of those, and where it's going to be surface destroyed, and it's going to take in a surface holder, and in here we're going to want to do a few things, and that is stop our current thread. So while retry equals true, and we of course have it start out as true. Then we want to try, which if you don't know what that means, it's just going to basically try and run that code, and if there's somehow an error, instead of crashing, it's just going to go to this catch. And it's going to pass the exception we get, and we're just going to print stack trace, which will print it out to our debugger what went wrong. And then in here we just want to set running to false, which will stop our game loop. And of course we haven't made that class yet, that's why we're getting errors. And we're going to do thread.join, which it'll finish running that thread, but then it will terminate it. And then if this try block succeeds, then we're just going to say retry equals false. And it'll keep looping because sometimes it'll take multiple tries before it works, and that's why we have it keep looping till it works. Now we want to override, I think this is the last method we have to override. It's going to be a public boolean, and it's going to be onTouch event. It's going to take a motion event, and it is going to later manage all our touch inputs, but for now we're just going to return the super call of the event. And that's just because we'll cover that in a later episode. And then we want public void update, which is not anything that we're overriding. It's just a method we're going to make. It's going to update our game frame by frame. And then finally, we want to override the draw method, which later will take in a canvas, which is what we will be displaying on screen. And it will basically draw everything in our game onto it so that it will display our game. So then canvas, actually just canvas we're just going to call the super method for right now. Alt-Enter to import, import class. Okay, Now we just have one more class left for this episode. Come over here to your package and create a new class called MainThread. I hinted at this earlier, but it's going to extend thread. And now we're going to create this class, which is going to be the meat of our game. So we're going to, for right now, make this public, and we're going to have a public static final int max FPS. And that's going to be equal to 30, and that's the FPS we're going to cap it at, because most phones, at least for a simple 2D game, will always be able to run 30 FPS, and usually well above, and that's why we want to cap it, because at some point it's just making unnecessary calls to the game loop, and we want to limit that. Now we want to store our average FPS. And we're going to have a private surface holder, private game panel, and our boolean, which is running, and we're going to have a public static canvas, and this is what we draw with, of course, alternate import, and then we're going to create our constructor, which is going to take in a surface holder. You obviously saw us making some of these methods in the game panel class, so you may have been able to guess what went in for these arguments. But then we're just going to call super, and our surface holder is going to become the surface holder. Make sure you include the this keyword, because they are using the same reference name. And now we want to override a method that is contained within the thread class, and that is the run method. And in that we want to define a few longs, which are basically just integers, but they can store up into a higher value, much higher. Max FPS, I accidentally typed this wrong, it should be 1,000, because there is 1,000 milliseconds equals a second. And then we're going to have wait time, frame count, which can be an int, because it's never going to get too big. It could really probably be a short, but we're not going to fool with that for right now. Target time is going to be 1,000 over max FPS. And you can see we're doing integer division right here. We're not storing it as a double, mainly because all that we're using this for is to wait on our thread and do other things which require an integer number for the milliseconds. And that's why we're just doing integer division to take care of that. And now we want to do while running, which you can see why now setting running to false could stop our game, because we're containing the meat of it in this while loop. And then we're going to have start time equals system.nanotime. There is a million nanoseconds to a millisecond. So that's what that is. It's a very accurate clock built into the system's hardware, Android system's hardware. So you only want to use it when you're doing really precise measurements, and otherwise there's another method you'll see that gets the time in milliseconds, which is less expensive on the system. Anyways, now we want to do a try catch block. Once again, just print it stack trace, and then we want to say canvas is equal to this dot surface holder dot lock canvas, and then we're going to do a synchronize on the surface holder, and in there we're going to do this dot game panel dot update, which is our update method in the game panel, which I told you about earlier when we were creating that class. And then we're going to do the draw method and pass it in the canvas to draw on. So that's basically, these two lines are the meat of our entire game. Because right here, this calls the update, which say you have a character that you want to move 2 spaces, right? In this update method, we'll have a game object that is the character. And this update method will essentially change the y and x value stored by that game object to +2. We'll add 2 to it. That would happen in this update method. The draw method, all that does is say, let's look at what the coordinates are right now and then draw it onto the screen. So they're 2 different things. We'll learn more about that later, but they're 2 very important pieces to our game. So next, what we want to do is add a finally block, which essentially just says even if an error occurs and we have to go into this catch block, it's still going to call this finally block. This happens no matter if we succeed or fail. And we just want to say if our canvas is not null, then what we're going to go ahead and do is we're going to try something. Just add in the catch. Print it stack trace. And in this try, we're just going to say surface holder dot unlock canvas and post canvas. So that takes care of that whole try catch finally block. Now we want to say time millis, which is our time in milliseconds, equals system dot nanotime minus start time, which of course right here is all in nanoseconds. So we divide by a million. I think I got that right. A million to get the time in milliseconds, as time millis implies. And then we're going to say wait time equals our target time, so what we're going for per frame, minus the time millis, which is what it actually took. And then we're going to try, not tray, of course catch, once again just exception E, and we're just going to print stack trace on all these. And then we're going to say if wait time is greater than 0, meaning we finished the frame earlier than the target time, then we're going to sleep there, where the thread is going to basically pause for that amount of wait time. And that's where we are essentially capping the frame rate. And then we want to do total time plus equals system dot nanotime minus start time. So we're adding to the total time. And we want to do frame count plus plus. And the important thing to note here is that this total time, you'd think just add time millis, but the important thing here is that we're calling it after we sleep, so it's going to be getting a different value. And then in this frame count, we're going to say if frame count equals max FPS. So essentially, since we have it at 30, it'll be sampling the average FPS every 30 frames. And then we're going to say average FPS equals 1,000 divided by another set of parentheses, total time divided by frame count, and then here divided by a million. And that just has to do with a bunch of conversions between, this is converting from nanoseconds to milliseconds, and then we're dividing 1,000 by the time it took, 1,000 being a second, and then divided by the time it took, and we'll get the average FPS. And then we're going to just set frame count to 0, so we're going to reset all these values so that it'll sample it again the next 30 seconds. And just as the kicker for this episode, we're just going to print out the FPS. So essentially see that we have created a game loop, and it is running properly. And one thing I forgot is we forgot our set running method, which you can put your getters and setters wherever you want. I'm going to put them up here with the variables. So just do public void set running. It's going to take a boolean running, and make sure, of course, you include the this keyword, because the argument has the same name as the instance variable. And that covers that. Let's check that this error goes away. main thread is abstract and can't be instantiated. Alright, so let's try and figure out this error. Okay, so if we look at our game panel, here's what the problem seems to be. We have this annotation inserted as an import for some reason. Go ahead and get rid of that. I don't know if that will have happened to you guys. This is the first time it's happened to me. But if it's there, delete that. And now, as you can see, we have no errors. And then you're going to just click Run up here. And we're waiting for the Android debug bridge to load. And then you want to do Launch Emulator. I'll show you how to set up an emulator in case you don't have it yet. So click this ... It'll take you to the Emulator Manager. Do Create Virtual Device. Choose whichever model of device you want, or device model you want. I did Nexus 5, and you just click Next. It'll ask you to fill in some details about it. You'll click Next. Once again, I'll have some more details, and I already have it, so I'm not saving it. But if you click Finish, it would download it onto your system, and you can now select it from this drop down. So I'm going to run the Nexus one, like I said, and this is notoriously slow. It depends on how fast your computer is, but I'm going to pause the video and get back to you guys once it's loaded. Alright, so the emulator has opened. As you can see by the log over here, it's installing. Now, of course, it just finished installing. And here's our app. It's just a blank screen because we have nothing in the draw method. It's not drawing anything on the screen. As you can see, we're getting a lot of output, but that's just because it just started up. And now that we have it running, you can see our FPS being printed. As you can see, it right now is not, it's not horrible, but it's not that high. It's only at 20, 23, 25, low 20s. But on a device, it should be reaching 30 pretty much the entire time. And so that's why we have a cap. And so that about wraps it up for this video. In the next video, we'll be going over some of the basics of canvases, and we'll hopefully set up an environment and get all that good stuff set up. So thanks for watching. Make sure to subscribe and stay tuned for the next video. Bye.